Okay, I'm going to talk to about the homework assignment number 1 today, because I think that's more urgent. And thank you for some of you actually came to my office hour yesterday, and from that conversation, I kind of realized some of the issue I need to address. So first, I like to I realized that some of you actually don't quite understand at this moment about what's the concept of a file. So can some of you give me a definition about what you think? What is a file when we say that in the programming sense? What's your definition about file? Yes, please.
It's like a collection of data with some formatting.
Okay. Hold on 1 second. Any other definition? So what you're saying is a collection of data and with some kind of format, right? That's what you're saying, right? What's your name? Aaron. Okay. Thank you, Aaron. Sorry, Aaron. All right. Anybody else? What's your definition of file?
I don't know too much beyond this, but I know for like Unix-based operating systems, there's a concept of a file pointer. And then like in C, you have an actual file struct, which like points to that file that you open up.
File pointer and file struct. And what's your name? Nicholas.
Yes.
Is that the right way to?
Without the H.
Like this?
Yes.
Okay, great. Thank you, Nicholas. Okay. If you look at this two definitions, they're quite different, right? One is actually from the operating system point of view. One is from a user point of view. So let me actually give you my definition of file in the context. There is no right or wrong answer, but I do want to say for homework assignment number 1 or in the Unix file system, usually this is my definition of file. A file essentially is a sequence of bytes. So what's a byte? It's just 8 bits. So what is a bit? It's a 0 and 1. I assume you're familiar with this concept. So 8-bit is 0 and 1. So therefore, what is a file? File is essentially something which is a lot of bits that put together. And it's a sequence. When I say sequence, that means the order of the bits in this file matters. Okay, so that's my definition about file, just a sequence of bytes. So Nicholas actually mentioned something which I'm not going to talk about, file struct, which is something you will learn later when you worry about operating system kernel, when you understand this. By the way, computer science major, I probably should use the mic. You will gradually advance your understanding about computer from the user point of view, which is we have been using computers since we're using device and internet. And gradually, we're going to move into the system view. System views means internal, and try to understand how to represent a file. And what is a file on your hard disk, or on your USB drive, or actually on the Google Cloud, which they actually have a file. So regardless, this file is actually in YouTube or Google or whatever, they're basically a sequence of 0 and 1 to say this way. So for example, when you go to YouTube, we actually streaming. And what is that movie we were watching was actually a sequence of bits and bytes, but represent the encoding about the video, audio, and some of the caption data. That's essentially, you can see that this is, the definition I gave is very simple, but it's a very application neutral that you can use this concept apply to any application, video, audio, data, or whatever, you name it. Okay, all kinds of data structure, as long as you can represent something using 0 and 1, and we can store it in a container we call a file. Okay, so this is the most lower level representation of a file. When Aaron mentioned about the format, there is an application view about the file. Because, for example, I could create a file for 0 and 1, a lot of 0 and 1, but I don't know whether this is a Microsoft PowerPoint or is a YouTube video, which is MP4. I don't know that. How do I actually realize the whatever format? The format only matter to the application. To the application of a Zoom, the application of YouTube, or application of Microsoft Office. And from the storage perspective, it's just 0 and 1. There is no meaning. And then it, depending on the application, try to interpret that. Okay, so that's my definition about a file. So since it's a sequence of bytes, when we do my break, is that I'm trying to break the file, the sequence. It could be a DVD movie. It could be a large database of all the social media user. And I can break it into smaller parts, so it's easy for me to do certain things. I mean, for example, it's probably really expensive for you to load all the DVD movie from, say, from a server that's actually to your computer, and then you start watching. So typically it is that you actually break the content into different chunks. And the thing is that if you want to watch the movie sequentially from the first bit to the last bit, then you basically bring in chunk in progress slowly as you watching the movie. Or if you want to do fast forward, I mean, that's very common. I want to fast forward, directly go to the last 5 minutes. I mean, by the way, that's the way I watch a movie. I usually watch the first 5 minutes and the last 5 minutes and then decide whether I want to watch that movie. Okay, I mean, I'm a spoiler and people hate me when they watch a movie with me. So what I did is I actually watched the first 2 chunks and then go to the last 2 chunks. I want to kind of watch that. Okay, if the application allows me to do that. So that's essentially a concept of my break. So my heel is actually opposite. My heel opposite meaning that, okay, I already have all the chunks and I want to put back to the original sequence of bytes or bits. You can think about that. If my, let me just give you an example. Assuming my file is kind of very small, okay, it's just 1001, no, not 2, I don't have 2. Okay, this is 1 byte, 2 byte, 3 byte, 4 byte. Okay, assuming I actually only have 4 bytes. That's my file, only 4 bytes, 32 bits. Okay, I mean, assuming I really want to break this into a tiny chunk, and each chunk is only 1 byte, then essentially what I did is I break this file. Oh, sorry. Into 4 chunks. Each of the chunk is what? Guess what? 8-bit. It's just 1 byte. It's a tiny chunk. Okay. So essentially, my break is breaking that first sequence, which is 32-bit, into 4 chunks. And then I can deliver to whatever platform people want to download this. And then when you want to put back together, so my heal program is that, okay, you have this 4 chunks, and I'm actually going to reproduce this file. So if you have a program, which is my break, my heal, they work correctly, then essentially the original file should be exactly the same bit by bit to the end product of my heal. So that's what the relationship between my break and my heal. Okay, so I'm actually going to tell you what you're going to implement. By the way, when you actually really look at the implementation, it's probably a lot better or easier than you thought initially. Okay, I will explain to you why. But let me actually show you some demo about how this might work. So over here, you see that I have a huge file. It's not that huge. Okay, let me pick this one. This one obviously is a CSV file I have created. By the way, this program I'm actually looking at, when I did this, I was actually looking for fake account on some of the online social media user before election of, I forgot, maybe 2020 or something like that. So I was worried about that, so I was collecting this. Okay, so that is a source. So let's try to do my break. Okay, so the source file, let's say source to ID. Okay, that's the file I tried to break. If you look at this file is about 469 megabytes. Okay, that file is a pretty big, I would say maybe some of the database or spreadsheet, but it's about half a gigabyte. All right, so I will do my break. So if you type my break, it will tell you, okay, you have to specify the command is called my break. There is a source, which is this file. And then prefix is how do I actually generate the chunks? What's the name? I will show you that. And then the chunk size, I mean, each chunk, how much you want to have. So I'm going to run this program, source, this one. Okay, I'm going to call my prefix ecs36b. Okay, this is a demo. Let me actually just do S2023. Okay, that's the demo for you guys. And chunk size is basically saying that it's a chunk size of k byte. So I want to actually make it, let's see, if I want to do each chunk 64 megabyte, how much k byte I should have? 64 times 1024, right? Yes.
5,536.
Great. Okay, you're my calculator right now. Okay, from now on. Thank you. That's the number. Is that right? Calculate. Oh, I'm sorry about that. 65536. Okay. Okay, I'm actually going to break that into 64 chunk. Okay, so you see that it's starting to break the file into chunk number 0, chunk number 1, chunk number 2, and the prefix is what I just type it in. So basically, I produce 8 chunks because the file is about half gigabyte and each chunk about 64 megabyte. So by the way, 64 megabyte is a very standard file size for chunk file size for Google file system, GFS. I mean, when you learn operating system later, you might have the opportunity to understand how the industry they're representing file. For example, GFS is Google file system, and Linux is actually take that idea, produce something called Hadoop file system. They're all following the same paradigm. Is having the 64 megabyte chunk. Okay, so I have 64 megabyte chunk. Let's actually look at their size. By the way, this is a Unix command ls-l. If I look at each of the file, you can see that that's interesting. My last chunk is actually 0. I'm wondering why. I might have some issue here, but you can see that each of the chunk is exactly 64 megabyte, but I'm thinking this one must have some size. Let me actually take a look. Do they have anything there? I'm surprised it doesn't have anything. Yeah, that's very strange. It doesn't have anything. Does the original size exactly power two? I'm surprised. Okay, but anyway, that's my break. I break into that because usually the last chunk will have some like a residual part about the file. Because let me actually try a different file. Let me try a different file using this one to sort LIS XLS. Let me actually try to do this. Okay, this time I'm not going to change this, but I'm going to change this to be number 2. And this one, I'm going to change this file to be this file. I'm going to break it again. This is even larger file, so I want to see the last piece. Okay, so let's actually take a look, ls minus L, and I want to say 02 star. Okay, you can see that now the last chunk is actually not 64 megabyte. It's a little bit smaller because it was a residual part of that. Okay. All right. So that's how we do break. So you break your file into different chunks and fixed size, chunk size, depending on how you specify. But now I'm going to tell you how to do heal. So before I tell you to talk about how to implement heal, I'm going to try to run it once so you kind of have some idea. So my heal actually has one more parameter. It has a source, has a prefix, has a chunk size, but it has a number of chunks because when you break it, you don't need to know how many chunks you have. But when you heal it, I need to know. So I can actually put it back. Exactly. So anybody remember how many chunks I have for let me actually take a look at this because the last one is 10. So that means I have 11 chunks. I think that's the, yes, I have 11 chunks. Okay, so what I'm going to do is using this. I'm using exactly my break command. You see, I'm using exactly the same line. No, actually, I have to switch over here. Let me actually try this again. My heal. Okay, source. Okay, so what I'm going to do is doing this line, my break. And then I'm actually going to say this one is dot healed. I changed the name of the source because the source is really misleading. It's really the target. I'm going to push it back. So I'm going to write the file after the heal into this name called toID sort LOLISXL heal. And the prefix is still the same. And the chunk size is still the same. And the number of chunks is 11, right? That's 11. Okay. Yeah. Thank you. Thank you very much. That this is need to go to my heal. Okay, so it's actually trying to reading each of the chunks. Okay, so now I'm actually generate this file called toID sort LO list. How do I know I'm doing correct? So I use a program called diff. Unix tool. There is a tool called diff. Is trying to look at the difference between this two file bit by bit. Okay, so I'm going to do diff. Let me see. Okay, yeah, diff toID source and toID source dot healed. Okay, you can see that when I type diff between these two files, there's nothing different. There's not. Let me show you that what can be different. Okay, so if I do diff between this file and I say the other file called back. Okay, this two file, I just run it for experiment. If I run it, it's a pretty huge file, so it needs to do a lot of check. Let me pick a smaller file. Is huge, so it's going to. I'm going to compare my heel.c to my heel, which is executable. Of course, they're different, right? One is a source code, one is executable. You can see, well, it's actually say they're different. You see me. Let me see. Let me do this. My break two. Let me actually try to give you something which is more. Yeah, I'm not going to bother with this, but basically, if it's a binary file, it basically just tell you they're different. Yeah, you have a question.
Faster to compare checksums.
You can do that as well. Yeah, you can also use checksum to do that. Yeah. Okay, so this is just want to show you what is a file. Number one, what is my break and my heel are doing related to the file, and how to check if your program is actually working correctly using diff or using whatever checksum you want to use. Okay, all right. So now I'm going to tell you how you're going to implement this. Okay, the best way for you to do this, you can see that my heel and my break is almost symmetric, because it has to be symmetric in order to produce exactly the same file. Even the name of the chunk that you name, there is actually have to be symmetric, but maybe some of the command become like a reverse order. Okay, so in other words, what I'm saying is that you should understand, take a look at my break, and then use my break and copy that into another file called my heel.c. and start to make some simple modification. Let me actually show you the difference. I actually did a diff between my break.c and my heel.c. And then for you to actually take a look, of course, I'm not going to show you the whole thing, because if I show you the whole thing, you actually get it done. But it's not too many difference. Okay, so I actually already put this difference called EE1. Okay, this two files are basically my heel. So when you use diff, that if it's not binary file, it's going to show you line by line about what's the difference. So basically, let me actually tell you what I run, so you know the command. So I do diff my break. Let's see my break.c first, and then my heel.c. Okay, so this is the difference. And then I'm going to store in ecs36b, S2023, homework 1, diff. Okay, I'm going to save that in this file. So it's actually going to save it here, ecs36b. So let's actually take a look at this. I want to show you, get some of the feeling about what's going on. It's being recorded, so you can actually look at the file and then see what's. Okay, so the first difference, you see that the format is, if you see a smaller sign, that means the first argument, which is my break, and greater than, that means it's actually the second argument or the third argument, which is my heel.c. So the first difference, of course, is I assume, if you don't know, if you see a C program or C++ program with // that means it's a comment. Okay, it's not a code, it's just for readability. So the first one is just saying that the file name is different. Of course, they're different. The second one is a usage. You see that my break take 1, 2, 3 parameter, and my heel take 3 or 4, one extra parameter. Okay, that's the difference. Okay, and the thing is that it used something called ARGB and ARGC, which is about the interface in a C program to communicate with the environment about how many arguments. So ARGC is argument count. Let me just refresh your memory in C programming. So you can see that this part is pretty trivial, right? Is just the argument has to be different because there's one extra argument to actually represent the number of chunks. And then this is just printf, is just printing the error message. If you actually didn't have the same argument, you will need to do that. Okay, so far so good. And this part you can see that this is only show for what? This part is only show for my heel. Greater than, that means it's my heel. This part you can see that is only related to the handling of that extra parameter called chunks. Okay, so there is a one part of the program, you have to deal with that. And oh, okay, now you try to open. Okay, now it's interesting. We're getting interesting. They're trying to do a Unix system called fopen, file open. And in the my break, when you open, you actually open the argv1, which is the in fact it's a second argument, but you can actually treat the first non-command argument. And let me just refresh your memory what's going on. When I run my break, this is the file I try to break, right? This is the file, 2ID sorted L. So that is the argv1. But when I do my heal, that is also the file name of argv1, which is .heal. Okay, so now let's actually go back to the I have to go through it slowly, otherwise I will show you too much. Okay, so essentially my break is fopen argv1, and my heal is also fopen argv1. The difference is read and write. So you open the file with the intention to read it. So for example, my break, I'm actually reading that huge file. I read with that pointer. By the way, there is a file pointer, which is every time you do after you open successfully, after you read, say 5 byte or 64 megabyte, it will move that pointer to the new location until you hit the end of the file. But my break, my heal is opposite. My heal is I'm actually reading the chunk, but I'm going to put things into this file. That's why it's actually argv1 is write instead of read. Okay, so let me actually show you the next difference, and that's it. Okay. You can see that this is, I have a loop. Both of them have a loop. I have to go through the whole thing. But my break is basically an infinite loop because I have to keep looping until what? I actually reach the end of the file. I don't know how big the file it is from the beginning, but in my heal, I actually know that is controlled by chunks. I know how many chunks I need to read. So this is going to be different. But inside the loop, they're still very similar to each other. Okay. All right. So what I have been telling you right now is that one way of developing this homework, I feel that's the best way, is to understand my break and use my break, make some modification, make it into my heal. And that's why I had a video which I sent it to you via Canvas. Sorry, not Campus, Canvas. Have you actually got my announcement this morning? Okay, so that was a video which I actually recorded maybe a couple years ago. I explained line by line about what my break.c is doing, because some of you might be already familiar with the C programming. But inside, because I need to deal with file, some of you actually didn't have enough time to actually learn about file operation. That's why I actually explained that to you. So my instruction objective is for you to make sure you actually catch up, you understand the C syntax, and somehow through the description, you start to be familiar with how do you actually use a call like fopen or fclose or fread and fwrite. There are probably 4 or 5 calls. There's fopen, fread, and fclose, fwrite, and the other one is rewind. because I actually sometimes you need to actually rewind the file. Remember, you have a file pointer, and that pointer sometimes you need to rewind it because you want to change, you want to control that pointer. What is a rewind? For example, you can rewind. You can actually also set at a later point because, for example, you want to do fast forward. So there are a few file related system call that you might want to actually take a look at the video. I will not repeat that the content here. Okay. Okay, but after you read the video and watch the video, after you try to do this, but if you still have any issue, please let me know. Okay. Any question? So yes, please. You have a question? Okay. Any other question? Okay. Yes, please.
For the file deal, is the source where we're taking or putting all the file pictures?
Yes. Yeah. So I want to clarify that. I probably. Okay, let me actually tell you what I feel I really need to do. So my heel, you see that when I do the comment, I actually use the target file. It's a target file, but in the when I actually write the program, I actually make I make this to be source. This one should be target. Okay. I should probably tell you what I did with this file. You see that? When did I write that file? 2008. That was 15 years. I was in Lake Tahoe, and I need to teach a class, and I want to transfer that file back to UC Davis. Okay, and the thing is that this is 15 years ago, and the internet speed is so fragile, and the web service at that time, it doesn't recover if your internet service break. Right now, it's a lot better. So at that time, I was really frustrated. So guess what? I mean, this is good to be a C++ programmer. And I just wrote my break and my heel at that time, because then I write a program, I break my long lecture into, I forgot. At that time, I probably only do 2 megabyte chunks, because at that time, 15 years ago, the network bandwidth is a lot smaller than today. Okay, so just to let you know this, and then I actually make the change when I actually fly to Washington, DC for another trip, and then I have to another issue. I kind of improve that to make it to work. Okay, so it's always good for a programmer. It's not just learning the programming, but just be sensitive to whatever surrounding challenge that you have, and then see if you can actually contribute to that challenge, to resolve that challenge using the programming skill you're learning. Okay, it's pretty much we're seeing that the computer programming become really influential to our society. Just a note to that. Okay, any question? Okay, so I'm going to dedicate Friday to homework assignment number 2, which is the Wordle. That is another program I can give you some help to say, well, how you can actually do this quicker. But this is, I hope my heel and my break shouldn't take you too much time. Okay, if you can follow the instruction or the video. Okay, all right, and just give you a hint. There are not too many places you need to change. Okay. Do it smart, not too many. Okay, now I have about 10 minutes. I can go back to object-oriented programming. Okay, so I mentioned that we're just to let you know, we're in chapter 11 of your textbook. We're in chapter 11, which is we start to talk about the concept we call a class. This is the first subject about this 4-chapter data abstraction polymorphism. So we first need to understand what is the concept of object-oriented, of course, the core concept is an object. So I'm not going to tell you a lot of programming yet, but maybe Friday and maybe Monday, you are actually receiving a GitHub link from me before the class about the program I will be presenting, which means that I'm going to talk about the program, and then you can actually start watch the program with GitHub, or you can download it, just run it as we went through this. Okay. So first, let's actually tell you what is an object. What is an object is, I want to use this picture to actually represent what is an object. Okay, I use this circle. You can think about a person is an object, a computer is an object, or is a device like this is an object. So when we say object, there is a few things we need to understand. The first thing you need to understand is that the object must represent some information or data. So typically you can see that this surrounding is the wall, is the boundary that try to protect this data that you store in the object. For example, if I consider a person object, then inside my brain, inside my thought, is either physical or cognitively that I have a lot of data that's within myself. Okay, that is a data. And the thing is that what is object-oriented is that we actually recognize we have a way to describe what do I want to represent for that data. And then the important thing, I want to protect it. Protect it means that I don't want anybody to directly access the internal state of my data. But instead, I define an interface. And this interface is a programmable interface, and such that when anybody else outside of object want to communicate with me, which is the internal data, they have to go through the set interface I have. Okay, so what is an object? Let me go back. It has some data or attribute. And it has some kind of interface, which is the method. That these two things together is called an object. All right, so I want to be, any question about this definition? You're okay with that? Okay, so just in practice, for example, I'm a human being. And of course, the internal data that I have is a lot of data, right? I have all the memory cell in my left brain and right brain. I have my physical part. I have my emotional part. I have my cognitive recognition. I have a lot of the experience that I have in the past 32 days, and it's all internal. And the thing is that a lot of time, the object is actually, the real world object is actually really hard for you to really even exhaustively understand that what they are. So what the idea of object-oriented programming, that's what I said. There's a programming part, there's a modeling part. So what the modeling part is really trying to do is that, okay, I want to decide in the context of my application, what are the most essential data that I care for this object? Then I basically will model that inside this object. And then I actually will define the interface over here or the method and such that will allow this object that I have chosen to put it inside the object, that this method will be able to access to that. So in other words, for example, when we model a class person, an object person, I haven't talked about class yet, sorry about that. So a person object that has, maybe I decide to have attribute like the age, name, social security number, and maybe some kind of data related to your job title or your status for a student, that you might want to include what courses you're taking and things like that. So you choose whatever attribute that's most relevant to your object, and then you basically just define that. Okay, so that's the concept of object. So now let's actually take a look at some example. I am using this example called Gradebook. No, I want to skip this one. This is actually the example from your textbook. Yeah, I will just follow this example. That's fine. So so what is a class? Obviously, if I want to define an object is what? A person. And in this room, we probably have 170 students. If I actually need to define for each of the student, it's going to be really complex. It's going to be, I have to find Nicholas, right? I want to see what is in Nicholas or what is in Aaron. That's the only two names I know so far. I hope you can know more names. Sorry about that. And the thing is that they're quite different. And again, they have some similarity. It will be really hard for me to decide what to do that. So that's why in object-oriented programming, we come up with a concept called class. Class is a generalization about all the object I try to model and just define one generic class. And use that class, then I instantiate, I create, based on that class, I create an object called Nicholas, I create an object called Aaron. By the way, I should say that in object-oriented programming, there are object-oriented programming language that doesn't have a class. They only have object, but they are not being used very, very widely. Okay, but there are. In fact, there are some object-oriented programming language. In theory, they're actually superior than the programming language we're using today. And they don't have class. They use other mechanism, but it's not so popular and just nobody use that. If a programming language, nobody use that, then it's essentially not very practical to learn about that. Okay. So we're going to look at the first class that from your textbook, which is, I think is, which chapter it is, I forgot. Okay. So it actually talk about a class called Gradebook. So you can see that this is a class. The keyword is a class. And then with the class name called Gradebook, and then has, forget about public at this moment, okay? Just neglect the public. And then you have a method, which is basically allow you to basically call the interface. This particular object, you don't have any attribute. So means that is empty. Yes, please. Yes, that's actually a very good observation. Class is actually similar to struct. In fact, okay, let me actually just ask, I'm not sure you all remember the concept of struct in C programming? Okay. So in the first implementation of C++ compiler is essentially generate the code for class into struct. So if you look at the compiler, today's C++ compiler is equal to minus capital E, some of the version of a compiler, you can still see the code they generate. So for a struct has multiple attributes, and essentially each of the attribute is being produced as each of the from the struct attribute. And then the method, like this method, is actually being generated as a function pointer that inside that struct. So essentially what is a class, if you understand struct, is a struct with a lot of attribute plus a set of pointer to function. And then the compiler is going to check for accessibility, meaning that for the protection, whether you actually be able to access this variable, that's compiler. The C++ compiler is going to be checking on that. By the way, I mentioned a term you might not, most of you probably not familiar with, is called pointer to function. Any of you heard about this term? Pointer to, some of you heard about pointer to function. Okay, so we will learn the concept called pointer to function. So you probably learn a lot one of the most difficult concept in C programming is a pointer. Usually we use pointer to a particular position of a memory. So that's called pointer to whatever address, the memory address. But if that memory address turn out to be the entrance point of a function that you can execute, then that pointer is essentially a pointer to function. So when you do a pointer to function, that means it's an address, but when you use that address, you're not looking at the data, but you actually try to execute a function to that pointer. So that's called pointer to function. Very powerful concept we will cover in this quarter. Okay, so I think I'm done here and I will see you on Friday.